Okay, so we will be, this is chapter 5 review. I'm going to be doing evens. So, in each triangle, M and P are the midpoints of the side. So, we want to name the segment parallel to the one given. Remember, a midpoint, when we connect two midpoints, we get a mid-segment. If you check your notes, you'll see that the mid-segment theorem says that mid-segments, which connect two of the sides, are parallel to and half the length of the third side. Third side being the one they do not touch. So, what we're going to do, on number 2, we're going to look at what they give us. So we're saying, hey, what's parallel to segment JK? So JK is right there. And so we want to look what's parallel to that. So we know that if we're talking about mid-segments here, it's going to be the mid-segment that doesn't touch it. Because if it touched it, it wouldn't be parallel. That gives us PM, or MP, as number D has it. Same thing for number 4. We're looking at parallel to NP. That's a mid-segment, so it connects sides IJ and JH. So it's going to be parallel and half the length of IH, or, as number C says, HI. See? 2 down. So, we just talked about how it is half the length. So, we're looking at number 6. We know that, so TU without that bar on top of it, see if we go back here, it's got a little bar on top of all the letters. Here it doesn't. That means distance. So we know that if NL is 24, then the mid-segment is half the length and parallel to it. So it's 12. Number 8, MK, if the mid-segment's 11, it's half the length of the third side. 11 times 2. 22. I'm circling those little hash marks to let you know that they are, in fact, a mid-segment. A mid-segment connects two midpoints. How do we know they're midpoints? If you look at the things I circled, it's saying that the distance from that point in let's look at number 6, okay? So, number 6, we got U. And those two little double hash marks there are saying it's the same distance from U to N as it is from U to M, which means U is in the middle. Same thing with T to M and T to L. No, that's not what I want to do. Actually, that's what I want to do. Cool. Okay, so 12, we're going to get a little bit tougher. Same general idea, except now we're throwing in variables. Now notice here, it says find EC. That's the distance from E to C. So it's going to be this right here. So we know we have the distance of the mid-segment is x plus 15. And we know that twice the mid-segment is going to be equal to the third side. So we're going to go 2 times x plus 15 equals x plus 18. We're going to distribute that 2. Use a little subtraction magic. Double down on that. And we get x equals negative 12. Now, I always like to go back and check when I'm doing numbers, when I get a negative number, because even though my x can be negative, there's nothing wrong with that. It is always something that I get a little wary about, because I can't have my lengths be negative. So, if I plug the negative 12 in there, I get negative 12 plus 15 is 3. If I plug a negative 12 in on the bottom, I get 6. So, EC equals 6, and 6 is 3 times 2, so we're all good. It checks. So let's go down to D. We're going to find DF on number 14. So DF, so we're looking at SR, that's our mid-segment. That times 2 is equal to DF. So we have 2 times 2x minus 10 equals 3x minus 9. Distribute. I put 40 there, it's 20. I'll go back and change it. See? So I get x, I subtract 3x from both sides, so I have x minus 20 equals negative 9. I'm going to add 20 to both sides, and I get x equals 11. Now I was asked to find df, and I know that df equals 3x plus minus 9. I'm going to plug in my 11, so you get 33 minus 9, or 24. When I plug it into SR, I get 12. 12 times 24 is... or 12 times 24, well, not that you care, it's 288. But 12 times 2 is 24, which means that the mid-segment is half of the third side, which means we did it right. So, on number 16, Now 16, we're dealing with medians. Now median connects the vertex to the midpoint on the opposite side. Now if you look at your chart, you'll see that your chart says there are two kind of special things about the median, or where the median meets. It's called the centroid. The centroid is the balancing point of the triangle. It is also it is located 2/3 of the distance from the vertex to the midpoint. That means that if we're looking at the distance from X to C, that's going to be 2/3 of the distance from, and C to G is the other 1/3. Now here, we know that XC, that's from vertex to centroid, is 2/3 of the whole. We then plug in, and we have 20, so 2/3 times xg. We're going to multiply both sides by 3/2 because that's how we get rid of fractions. When we want to move a fraction to the other side, we multiply by its reciprocal. So multiply both sides by 3/2, and we get 30 equals xg. And that makes sense because 20 is in fact 2/3 of 30. So for number 18, again, this is a median. How do we know? Because it said they were all medians up top. So, find the AH if GH equals 19. So we know that GH equals 19. That's the whole length. The median hits the midpoint. A is the midpoint, which means that from A to H is going to be half of 19. So A to H equals 19 divided by 2. Or 2 times AH equals 19. So AH equals 19 divided by 2, or 9.5. Okay. Now, number 20. 20 is a little bit trickier. Find X. Okay. So we have two of our medians here. We have these two. We still know that they're medians, and so we know that this right here is the centroid. So let's first write our relationship down. We're comparing KR, which is the whole thing, to AR, which is going to be 1/3. So we know that AR equals 1/3 of KR, or we can multiply both sides by 3, and we get 3 AR equals KR. So now what we're going to do is we're going to plug in our variables, or variable terms rather. So we have 3 times 2x plus 7 over 5 equals 9/5 x. We just plugged it in for AR, VR. Our KR. So here we have these two 5s, which is going to be a real pain in the butt. So we're multiplying by 3. This is going to get ugly. So why don't we just go ahead and multiply both sides by 5? And that's called clearing the fractions. Okay, so we multiply the entire equation by 5. It gets rid of those fractions. When you clear a fraction, you want to multiply it by the least common multiple of all of the fractions. In this case, both of the fractions were 5, so the least common multiple is going to be 5. Moving on. So now we have 3 times 2x plus 7 equals 9x. We are going to distribute that out. Subtract 6x from both sides. And divide by 3. So we get x equals 7. And that's all they were asking for. So we're good to go. Next problem, 22. We're looking at FV and FW. So they're both on one side of the midpoint, which means they're going to be equal to each other. So we just subtract x from both sides. We get -1 equals x minus 7. We're going to add 7 to both sides. And we get x equals 6. Okay, so we're going to 24. So now what we're going to have to do, it's a little bit more difficult. We're going to have to solve for x and then plug x back in to get a distance. So here we're looking for the distance from F to D. Excuse me. So here we're looking at FD, which is 2/3, and FP, which is the whole thing. So that FD is 2/3 of FP. We're going to plug that in. We get 2x plus 10 equals 2/3 times 6x minus 6. Now when we distribute that 2/3, we're going to go times 2 divided by 3, or divide by 3 times 2. Either way, we get 12 over 3, 4, or we get 2 times 2, 4. So we have 4x minus 4. And again, so you guys know, that's 6 times 2/3. And 6 over 1 times 2/3 equals 12 over 3 equals 4. Okay? So we're going to subtract 2x from both sides. We get 10 equals 2x minus 4. We're going to add 4 to both sides. And we get 14 equals 2x. Divide both sides by 2. And we get x equals 7. We know that FD equals 2x plus 10, so we're going to plug that 7 in where the x is. That gives me 14 plus 10, or 24. To plug the 7 into FP, which is the whole thing, we get 42 minus 6, or 38, and 24 divided by 38 is 2/3. So we're good to go. So 26, same idea. Here we have VT. That's what we're looking for. Now this is a little tricky, because that's our 2/3, right? But we're not given anything with that. What we are given is we're given the full length, VH, and the 1/3 length. So we know that TH is 1/3 of VH. Okay, so we're just going to solve this. That's going to give us our x. So we write our equation, plug in our values, distribute. That gives us, I switched around, so I went 3 times 4x is 12x, and 3 times negative 9 is negative 27. So we have 12x minus 27 equals 2x minus 2. Subtract 2x from both sides. We get 10x minus 2 equals negative 2. I'm going to add 27 to both sides. And I'm going to get 10x equals 25. Now this is unfortunate because my answer is going to be x equals 2.5. Now, if I know that TH is, so VH, that's the whole length, is 2x minus 2, or 2 times 2.5 minus 2. 2 times 2.5 is 5. 5 minus 2 is 3. So VH equals 3. If I look at TH, 4 times 2.5 is 10. 10 minus 9 is 1. So if I know that this is 3 and this is 1, then that's got to be 2. And it makes sense because if VH is 3, then 2/3 of 3 is 2. Okay, so looking at 28 down here. The two small numbers, when we're doing these, the two small numbers have to be larger than the big number. Okay? So we have 7 plus 9 is greater than 18. 16 is greater than 18. Nope, not true. So remember, what we're dealing with here is the fact that the triangle inequality theorem says that two sides of any triangle must be larger than the third. Now look at number 27. Now here, why I'm doing this one is because it shows that it has to be larger than. Here they're equal to each other. Still can't happen. Okay, number 28, or number 30, we have 6 plus 6 is greater than 10. 12 is greater than 10. That's true. Number 32, we have 12 plus 8 is greater than 20. 20 is greater than 20. That is not true, so no, those can't be a triangle. Same rules apply to the next one. We're going to have a third side x, and we need to find out what x could be. Now remember, 10 plus 8 has to be larger than x. 10 plus x has to be larger than 8, and x plus 8 has to be larger than 10. Well, that middle one we can kind of get rid of. The bottom one I'm going to rewrite as x is greater than 10 minus 8. So the top one we end up with x is less than 18. Bottom one we have x is greater than 2. We get rid of the middle one because we're talking about length here, and length has to be positive. We can have a negative length. So 10 plus any positive number is going to be greater than 8. So that really doesn't limit us at all. So what we're going to do is we're going to have 2 is x is greater than 2 and less than 18. Any number in between 2 and 18 x could be, and we can make a triangle of that. 2 or less, can't do it. 18 or more, can't do it. Let's look at 36. So we know that the sum of them goes on the right and the difference on the left. So if we have two sides which are 12 and 11, the third side needs to be greater than 1 and less than 23. Same thing for 38, difference on the left, sum on the right, 1 is less than x is less than 15. It really is that simple. So, I'm going to quick pause. I'm going to switch over to the other portion of it, but we're done with the first half. And we're back. So, number one, it's a story about a sinkhole, but what we're really looking at here is the fact that we're connecting two midpoints. When we have a midpoint connect, that wasn't very good English, was it? Then we have a midsegment. Midsegment is half the length and parallel to the third side. So, 140 feet. Okay, that's 280 divided by 2. Now, over here, okay, so here's what's happening. Okay, so we have AC right here. This is our AC right here, okay? That is a segment. Now, these two right there say that BD, that's this part right here, is the bisector of it because it cuts it in half. How do we know it's in half? See those two little marks? It's in half. We also know it is a perpendicular bisector because it hits it at 90 degrees. Now, we know that any point on BD is going to be the same distance from our endpoints. Well, D is a point on BD. So now it's going to be the same distance from our endpoints. This is the perpendicular bisector theorem. So we're going to go 2x minus 3 equals x plus 2. So add 3 to both sides. We get 3x equals x plus 5. We're going to subtract x from both sides. We get x equals 5. So that's our answer to number 9. X equals 5. Number 10 says find the length of AD. Well, AD is 2x minus 3. So we're going to go 2 times 5 minus 3, or 10 minus 3, or 7. Find the value of y. Well, here, slightly different. So, here, we have this angle right here. We have ABC. Okay? And we know that BD is the bisector because of those two little marks. Those two little marks mean it's the same angle. If you have the same angle on each side, that means your little segment BD is in the middle. If it cuts an angle in half, which is what the middle does, it's the bisector. So we know that any point on the angle bisector is equidistant from both the sides. We know that the distance from a point to a line is the perpendicular segment. See? Perpendicular, perpendicular. Good to go. So we know that y plus 5 is the same distance as 3y. We're going to subtract y from both sides. We get 2y equals 5, or y equals 2.5. Which again sucks that we're using decimals, but oh well, we can handle it. We're big boys and girls. So y equals 2.5. We need to find the length of EG. We know that EG is 2.5, or is y plus 5, so we're going to do 2.5 plus 5, or 7.5. It's getting late, and so I'm going to talk through what I just... Okay, so the proofs... So we need to prove that ABC and are collinear. So really what we're going to do here is we're going to start off with all our givens, okay? That the distance from A to P and the distance from A to Q is the same. We're going to go the distance from, that's that right there. We're going to go the distance from B to P and B to Q is the same. And we're going to go the distance from C to P and C to Q is the same. So what we're saying is that A, B, and C are all equidistant from P and Q, okay? Okay, that's the definition of congruent segments. So now what we're going to say is we're going to say they're all collinear because and that is the converse of the angle bisector theorem, or actually the perpendicular bisector theorem. Let me erase that and rewrite that. So the perpendicular bisector theorem says that any point on the perpendicular bisector of a segment is equidistant from both of the endpoints. So it says if I draw a segment right here and it's perpendicular bisector, that I can pick any point on here and the distance from that point to both of the endpoints will be the same. Now, the converse of that is that if a point is equidistant from both of the endpoints, it is on the perpendicular bisector. So we know that this is on the perpendicular bisector of PQ, right? Because it's the same distance from P and Q, as is B, as is C. Well, there's only one perpendicular bisector, so it's got to be right there. 14, I really didn't go into because it's a pain in the butt, but really what we're doing here is, I'm going to explain it because I just don't want to write it down, so I'll do like a verbal paragraph proof. So what we're trying to prove is that if I drew this line right here from A to X, that is the angle bisector of angle A, okay? And this is how we're going to do that. We know that CX right here bisects BCM, okay? Now, in saying that, what it's saying is that any point on this line right here, this right here, is going to be equidistant from both of those sides, here and here. Okay? Now, that's one. We're going to do the same thing over here. And we know that X is going to be equidistant from both of these. Boom and boom. So notice that if we kind of put those together, and what we do is we would actually end up using the transitive property. We know that X is the same distance from this side as from this side. And we know that if it is equidistant from both the sides, then it's on the perpendicular, or on the angle bisector. Okay. Find the equation slope-intercept form for the perpendicular bisector segment with endpoints there. So what you got to do here is we got to kind of look at the segment, find the midpoint, because we know the perpendicular bisectors go through the midpoint. We find the slope of our original segment, use the perpendicular, use the fact that perpendicular lines have negative inverse slopes of each other. And then we are going to put it into slope-intercept form. So we end up with y equals 10/7 x plus 1/7. Okay, number 16, find the center of the circle you can circumscribe around ABC. That means we're looking for the circumcenter. Now each one of these is a right triangle. Okay, so remember in your notes you have that the right triangle is the midpoint of the hypotenuse. So really on 16, 17, and 18, all you have to do is find out which 2 points are the endpoints of the hypotenuse, in this case B and C, throw them into the midpoint theorem, or midpoint formula. x1 plus x2 over 2, y1 plus y2 over 2. This is something we've been doing since literally the second week of school. And you get that 1, 5 is the circumcenter. I don't know what just happened. So that's how the other two would look. I'm not going to go over them because they're the same thing. So looking at number 20, find the value of x if QC is 2x plus 3 and CS is 5 minus 4 times x plus 1. This doesn't make sense. So don't do, if you get stuck on number 20, don't do it. Okay? The point of the angle bisectors is C, and we know then that C is going to be the incenter, which means it's the same distance from all of the sides, like that. But we're measuring it from the vertices, and there's nothing about the incenter and the relation to the vertices that we've gone over. So don't worry about that. Moving on. Okay, so we're going to go on to number 26. If A, B, and median and altitude of perpendicular bisector are none of these, no. So let's look at A. A connects, or 26, AB connects the vertex to the midpoint. So that means it's a median, because it connects the vertex to midpoint. That's how we know. That's what a median does. Okay, number 28, AB goes through the midpoint B. How do we know it's a midpoint? Got those little neat, little nifty things right there. And it goes through at 90 degrees. So it's a perpendicular bisector. It's through the midpoint at 90 degrees. Okay, moving on. Yeah, this is longer than we thought, huh? So find the coordinates of the orthocenter. That's just check. So the orthocenter is where the perpendicular bisectors meet. Not the perpendicular bisectors, the altitudes. So the altitude goes through the vertex to the line containing the opposite side at 90 degrees. So what I want to do is graph them, take the opposite point. So there, I'm going to take, because we have on 30, we have 2, 5, and 2, negative 1. We're going to find the mid. So we know that that's a horizontal or a vertical line, which means that it's a perpendicular pair is going to be a vertical line. The vertical line that goes through 6, 2 is y equals 2. Okay, now the other one, we need the slope of BC, because we need the line that we're drawing to be perpendicular. It needs to go through A, perpendicular to BC. So the slope of, we're going to use the slope formula, x1, y1, x2, y2. So slope formula is slope equals y2 minus y1 over x2 minus x1. So the slope of BC is negative 3 over 4, or 3/4. So perpendicular to that is negative 4/3. So we know it goes through the point 25, so we're going to put into point slope. And then we know that y equals 2, so we're going to plug that in there. And that's going to give us the intersection of the 2 points. So 2 minus 5 is negative 3, 4/3 x minus 4. We're going to add 4 to both sides. So we get 1 equals 4/3 x. So we multiply that by negative 3/4, or 3/4 rather. So we get x equals 3/4. So the point of intersection there, the actual orthocenter, we would write as 3/4, 2. That would be the answer to number 30. Okay, 32. Tell which line contains each point phrase B. So here we need, what I do if I were you is I'd pull out my little chart. It shows the circumcenter is the perpendicular bisectors. So perpendicular bisectors, let's find one. Well, that's right there, because it goes through that line halfway at 90 degrees, perpendicular bisector, K. Orthocenter is the altitudes, right there. So if that point of concurrency, which is where all 3 altitudes meet, it's got to be on line M. The centroid, line L, and the incenter, line N. Okay, so 40 and 42, we've already done these. So 2 plus 3 is not greater than 5, so that's a no. 42, a plus 9 is 17. 17 is not greater than 18, that's also a no. 44. Okay, so 43, 44, and 45 we didn't go over, but they're pretty self-explanatory. The larger sides are opposite the bigger angles. Okay? So opposite, so we know that all 3 have to add up to 180. So if we have a 53 and a 60, then we know that that is angle B. So measure of angle B is going to be 67 degrees. So we know that the smallest side is across from the smallest angle, medium side, medium angle, longest side, longest angle. And so JB is our shortest angle, PB is our medium angle, and PJ is our longest angle. I say angle, I mean side. Okay? 46, we're almost there, guys. In PQR, so I just kind of sketch the triangle, fill in what I'm given, and so I know that angle P, or angle R, is the shortest angle right here, or smallest angle, so the shortest side is across from it, PQ. The next one up is 55, across from that, QR. And finally, we have the 82 of angle Q, biggest angle, so the larger side is opposite that. Okay? Now, number 49, we've done these. This is the Hinge Theorem. If an angle is, if two triangles have two congruent sides and not congruent included angles, then the larger side lies opposite the larger angle. So here, if we have XZ, that's got to be bigger than AC, because this is the same, this is the same. BC is the same length as YZ. But because we opened up those two on that hinge larger, then XZ has to be bigger than AC. I don't know what just happened. Okay, now let's look at number 50. Now 50, check it out. 50, we have this side is the same. Good. We have them sharing a side. Good. But look at what angle we're talking about. We're not talking about the included angle. The included angle would be this one and this one. Instead, we're talking about these peripheral angles. So, no conclusion. Okay. Number 51. Now, here we go. We have a 13 and a 17. Check. We have a 13 and a 17. Cool. We have a 12 and an 18. So we know that... Oh, I don't know what just happened. Okay. So we know that because of that this angle right here has to be bigger than 45. 5x minus 10 has to be bigger than 45. I keep hitting the wrong button. So that gives us 5x is greater than 55, or x is greater than 11. Okay? So we also know that 5x minus 10 has to be less than 180. Makes sense. Add 10, 5x is less than 190, x is less than 38. So any number between 11 and 38 is possible. I know that was not an even number, but I did it anyway. I'm a rebel. Okay, I'll do the even for you here. We know that because the 9 is bigger than the 6, that 30 is greater than 3x plus 7. We also know that 3x plus 7 has to be greater than 0, because you can't have an angle with 0 degrees. So we end up with 7/3 is less than x is less than 12 and 1/3. Okay. Finally, we have number 54. We're comparing AB and BC. Okay. AB, BC. So with AB, we know that we have these two sides, and they match up with this triangle with those two sides. We know that 79 is greater than 59, which means that AB is greater than BC. Okay? Good luck tomorrow, everybody. I'm going to go get this posted.